So today I'm here talking about building like physical objects that you can make games that are part of, or make games for. So I've built a couple of things throughout my time making things, and I'm going to tell you about them. So pretty much I'm just going to tell you about them with the hope that you'll see them and go, hey, that's not actually that hard, because I'm not really all that competent at making things. I've just tried and ended up usually succeeding. So you should feel like you can as well. So the first thing I'm going to talk about is we built an arcade cabinet for Wild Rumpus, for the London Hackspace. It's called the Beast, and it's amazing. So the way we built this arcade cabinet, we were kind of inspired to make it because of there's this network of arcade cabinets going around called the Winnetron Network. And we were like, that seems cool, we want one of those. So we decided to make one. And the London Hackspace had an arcade cabinet in there. It was donated. It was kind of running Puzzle Bobble, which is one of my favourite games. So I was kind of sad to put it on. That is it as we saw it, as when we first got it. So it was running Puzzle Bobble, which was one of my favourite games, and then the Neo Geo thing started flaking out and it stopped working properly, so then we were like, yes, let's gut it, and put our own stuff inside. It was actually fairly easy to replace it. We gutted out the parts, we replaced the 320 by 240 resolution screen that it had inside it. We gutted that out, we built like a shelf and put a CRT monitor in because it felt like we should have a CRT monitor in it. Which was a terrible idea because it just means it's really heavy. We then needed to hook up the controls, which we kept the original controls, which you can see at the front there. So we kept the original controls, we needed to hook them up. It turns out that hooking up like arcade controls to a computer is really easy. You just go on the internet and then there's a shop online called Ultimark that sells you a thing, and we actually ended up cutting it off and you just cut off the wires, insert the wires, plug it in, and it appears as a keyboard device. And then that's all you need to do to get that working. It was really simple. It turned out there was in fact even a device where we could just literally unplug the thing where it connected, plug it in, and it would start working. But we didn't realise we could buy that until we'd already chopped the wires off. So we had to buy the slightly more involved one. And like that was pretty much most of the hardware work. And most of the hardware work really for this was just chopping it to pieces. And in order to fit in the screen inside, it turns out the carpentry is really hard, but electronics is really easy, which is a theme I will return to. And so I'm just going to show you like our scrappy drawings. Like this is the detail of drawings you need in order to rework stuff. And so we finally got Jerry Carpenter, who I don't think is here today, but he drew some amazing illustrations. And then most of the build cost of this went on just buying these gigantic vinyl stickers to go down on the side. So this is a final shot of the side, stickers on the side. Look at how wonderful that is, and that's it being shown. I think at our first Wild Rumpus we had, but look how amazing those stickers are. So so most of the build cost came from that, and the rest of the cost, like we got a shuttle computer donated to us, we picked up a screen off Gumtree. So pretty much most of the cost was buying some really lovely stickers, so it would look beautiful. There's also some lovely kind of stuff on the front as well, which I don't have a picture of. So the other thing, the next thing I'm going to talk about is I tried to build this kind of helmet with vibration motors in order to play a game. So the idea was you'd make a game where you put on a helmet and it would just vibrate and you wouldn't be able to see anything, and you just kind of navigate via these vibrations you see. And this is not an original idea, so I'm going to show you the video that inspired me to make this, if it will launch. Come on. So here, this is like a headset thing, and it's got little kind of laser rangefinder things, and when the rangefinder things go off, it vibrates. And this man is blindfolded, and someone's like thrusting a ball towards his head. And they've not been told how this system operates, they just have this equipment put on them. And when the ball comes towards your head, you kind of naturally flinch away from it. Which is amazing, right? And so I thought this was really inspiring, because the really inspiring thing is they don't have to be told how to operate it. They're naturally flinching away, which is like, a control, you don't even need to be told what this thing represents. You naturally have a response. That would be great. So yeah, I tried to make that. And I prototyped it, and I originally actually prototyped it. I used kind of little rangefinder things, and I think this is actually a pair of tights I chopped up, so it would stretch around someone's head. And there's lots of wires, and it turns out that people found this scary to put on their head. What? They were just some tights I found at the Hackspace. in the box of like scrap material, because you know you've got a problem and you look around and you see something that could solve it, so you use that. And this was really I made this and it kind of worked. I kind of blindfolded myself and started walking around my basement, just so you could feel when you're about to walk into stuff. And then I moved on to the stage 2 of the project, where I moved it into a construction worker's helmet. And this has got because it's got like a face mask thing, so it's spray painted that black so you can't see forwards. And I put some headphones into the ear protectors, and then I taped an Arduino in there. And you can see the vibration motors in there. And so like one of the most challenging technical parts of this project was getting the vibration motors so you could feel them, which is why they're on little bits of plastic. It turns out that turns out to then be your most pressing technical problem. In terms of actually communicating with it, you use an Arduino, and you don't even need to write any code for the Arduino. You can just get a thing called Fermata, which is a protocol that the Arduino talks, and then it talks back to the computer so you can control the thing from there. And I made a little bridge so that you can control that directly from Unity. So this is actually the scene that you were moving around in. Obviously, since you didn't need to see anything, it doesn't matter about the graphics. So you were just navigating around through the scene, and everything was making sounds. But I kind of gave up on this because the feedback was really ambiguous. It turns out that when you turn around, you don't know how far you've turned around unless you've turned around in real life. So I'm thinking I may revisit this now that the Oculus Rift exists. And also the other thing is that most of the feedback you got was from the headphones rather than anything else. But actually building the thing was really exciting and easy. It's just a shame it didn't work. But that's the point of like experimenting and trying this stuff, right? It's you've got to try it, see if it works, and I still want to make it again. Hopefully learning from it and making a better thing. So the third thing I'm going to talk about is a game that I made. I was originally commissioned. A game I was originally commissioned to make for hide and seek, and this is Punch the Custard. So you can see Punch the Custard is quite literal, right? You can see those 2 bowls of custard there, people punching it. I have a bowl of custard here, if people want to... I might actually do the kind of primary school thing, like pass it around and touch it. So this is a bowl of custard. I mean, it's not really custard, because it's not. But it is custard powder and water. It's not... I guess you make this kind of fake bird's custard by putting milk in and heating it up. I'm not doing either of those, but it's really fucking weird stuff. And it's amazingly gloopy. So the whole idea of this is that if you poke it hard, your finger kind of bounces off. But if you put your finger in gently, it goes in like a liquid. So I'm just going to pass this around the audience. Is that the thing we can do? Alright, so the idea for this game came from the name. I wanted to make a game called Punch the Custard, and then I thought, what's the most literal way I could make a game called Punch the Custard? It turns out you just get a bowl of custard and punch it. So for the way the game actually works is it measures the number of times you've punched the custard. You can see the bits of tinfoil in this. So you put one hand on the tinfoil and one hand punching the custard, and as soon as you do that, it completes a circuit. The best way to do this would be to buy a thing called a Makey, which was one of the kind of inspirations for the project. Unfortunately, I made it slightly before the Makey's had shipped. So what I did was I went onto the Makey website and I found a place where they put schematics for how they make them, and then I stole those and made a copy of it myself on an Arduino. But it's really simple bits of wiring. I just made it on a breadboard. So it's really, simple to get working. It took me pretty much a day to write all of the code for it and everything else. There's some more pictures of people punching custard. Look how happy she is. Look how excited she is. Yeah! And this is actually a screenshot of the game. You can see how much effort I put into the graphics for it. So like a lot of this design of this game, a lot of what this game was just about how weird it is to touch custard. which if you felt it, like it's really weird. Like I think the game is probably less entertaining than just playing with a bowl of custard. I think I actually took an exciting thing and made it more boring, but I made it into a game, which means I have an excuse to take it around and show to people. And this is kind of the really interesting thing about designing for these physical objects, in that you have these constraints of the thing you've made, you have the constraint of the helmet. Like, the game might actually work if there was more than 4, or if those bits of plastic came out slightly further, which is a weird thing in designing a game, and then it's like, no, the game doesn't work because this bit of plastic is wrong. The other thing that's really important with Punch Custard that really kind of makes it work is the fact that I wear an apron when I'm showing it. And I always make sure that there's nice tablecloth on the table we're showing it on, and I always make sure that the things of custard are displayed. And I try to mix it up with wooden spoons and give you a kind of real feel of being in a kitchen. Like that setting is super important. In the same way that with the headset thing, people don't want to put this thing covered in wires on, but putting on a helmet where everything's taped down and kind of hidden feels fine, and everyone's willing to put that on. That seems fine. Like the actual presentation of your game, like physically matters. And another great example of this is Laser Nights out in there. June came around and was like, yeah, I'm going to go buy some pallets. I'm going to go find some pallets and borrow a screen and construct it all. And it's amazing. And Laser Nights, I'm sorry to say this, I don't think it's a very good game, but I really admire how well they present it and how much energy they put into it. It's an amazing phenomenon, even if it's not the best game. So finally, I'm going to talk about Tenya Wanya Teens. So Tenya Wanya Teens came about when we were preparing for the Wild Rumpus party, and someone had the idea of like, hey, instead of just putting on games that are already created, how about we have the stress of putting on a party and the stress of developing a game for it? And everyone went, yeah, that's a great idea. Let's see if Kota Takahashi wants to be involved. And he was totally involved. And so the first thing he did was he pitched us the idea of making a game for these 2 kind of strips of LEDs that you could individually address, and you kind of be chasing lights along. And like we looked at this and thought, it's a really great idea. And then I looked at a website and saw the cost of individually addressable LED lights and said, no, we can't afford that. Which I think is the most contribution I had to this whole project, was just saying, no, can't afford that. And then we came up with an idea where you'd have a controller with like 16 light up buttons. And I said, yes, that's within scope, we can afford that. Went onto the same website, and again, like the physical form designing for it. So this is like, when the components first came around, that's actually the cardboard box that all of the stuff arrived in. So I just put it in, just to feel how it's going to be set up, like the arrangement of the buttons, like how large a span that ought to be. Like that joystick isn't mounted at all, it's just sat on another smaller cardboard box. And none of these buttons work. But like, setting this up is important, just to feel how it's going to work with the kind of material, work with these kind of physical constraints. So then we developed it more. We put together lots of wires, and I shot art and photos whilst we were doing it. You can see just the amount of wires that go into it, but all of the parts here were pretty much just bought and then assembled according to the instructions you see on the website. The kind of electronic part was easy, and like, that board over there is the same thing we used in the arcade machine, actually. It's exactly the same encoder. You just plug some wires in and it works. That's the board that's specially designed to drive these LED lights. And here you can see in the box file form, because that's the easiest way to make things. You just get an already existing box and put it in. And it's actually running the party. And here's the actual game. So again, with this, the hardest thing is carpentry. Carpentry is bloody pain in the arse. So I just want to shout out, hey, thanks Alice for helping me drill holes in things and use power tools. And that really worked out well. Like you can see the pictures of the party, and it was successful. It got on gaming websites, but the game itself only works with these particular controllers. Which is a problem now because it was popular and we want to sell it, but it turns out it's a whole bunch of work just to make a single set of controllers for people to play it. So now we need to redevelop the game in order to not fit into these particular controllers. So yeah, I hope you've seen that carpentry is hard, electronics are easy, and that making things for particular objects is an interesting space that you should totally play around in if you have any ideas for it.